All right, now that we got our playing field shrinking, we need to confine the player's movement to the inside of my playing field here. All right, so what we're going to do is we're just going to jump right into it. First, we need to be able to access the current size of my playing field. I need to be able to have some variables that tell me how big my playing field is, where it's at, all that stuff. So we're going to need something to hold its current position and its boundaries and its scale, rather. So something really nice is happening here. Since I'm working with a square playing field, you'll notice, I'm going to go ahead and press play, that my positions are all kind of the same, right? They're all values of 10. The only thing that changes is, if it's negative or positive, and if it's X or the Z axis. So we got a lot of continuity or similar, I guess, characteristics between our different boundary cubes here, our boundary walls. So that's going to be really important, and being able to determine what position all the four walls are currently in. So why don't we shrink it a few times, and let's look at the values now. So my bottom wall right here now has a negative 7.8 value in the z-axis. And in my left axis, or let's look at my right axis, it's positive 7.8. So our values are staying the same. The only thing that are changing is what axis they're in and if they're positive or negative. So we can use those similar value qualities to our advantage here and making a general value for our x position or our z position and our scale as well. Because look at our scale. My right scale is 15.6. So is my left boundary scale. So that'll be handy too. So what we need to do is we need to make some variables that hold the current size and position of all of my boundaries. And since they're all similar to one another, one value for each of those variables will be all we need. So why don't we first start out by creating some static variables that we can access in any of the scripts that we have in our game here. So I'm going to say under my public static, I'm going to make some new public static variables, but this time they're going to be floats. Or, I guess we just say float. And what we need to make are boundary position and boundary scale. These two values right here are what we're going to use to determine the overall scale and position of our playing field. That'll be most useful when trying to confine our player into these values themselves. All right, so what we need to do now is we need to assign values to boundary position and boundary scale. So let's see. I was just going off about how all these values are so similar. So what I'm going to do is I'm just going to pick one of the boundaries and use that as the template boundary that I'm going to pull my boundary position and boundary scale from. All right. So I'm actually going to go into my right boundary if statement right here that we just made last video. And I'm going to do 2 lines of code. I'm going to say boundary pos equals boundaries and then our counter variable because we're looking at our current cube within our array here. So boundaries I, which is pointing to our right boundary cube, dot transform dot position dot x semicolon. Do the same thing for boundary scale equals boundaries bracket I transform dot local scale dot z. So why don't we go ahead and make let's use debug.log to make sure we're getting the right kind of value so we know exactly what our boundary position and our boundary scale are every single time we want to. So in our update function, this is our test right here. Since we don't have any penalties coded into the game yet, we're just testing the shrinking of our playing field by pressing the Q key. So I'm going to go ahead and expand this if statement with some brackets because I'm going to have to put in a few extra lines of code here. And what I want to say is debug.log. And what am I going to say? I'm going to say we're going to print out the boundary position plus, and then let's do some dashes, plus boundary scale. So every time I shrink the playing field, it's going to print out the general boundary position and boundary scale of the playing field. So let's see that in action here. All right, so we start the game and look at my console down here. So I press and shrink it. So we get a position of 9.8 and a scale of 19.6. So let's see how that pertains here. So we're looking at my right cube right here. Yep, the position is 9.8. I'm looking at my left cube and 9.8 as well, but it's negative this time. I look at my bottom cube and 9.8 in the z-axis and negative, but it's still a value of 9.8. That's the main thing we're looking for when trying to get the overarching size of our playing field here. And you'll notice that my scale is actually 1 unit larger and my bottom one, but that's because we were scaling up the top and bottom boundaries to cover up that space. So this is what it looks like without. So we get these little gaps in the corners of my playing field. So that's why we've scaled up the values of my top and bottom just a little bit, just to close off those gaps in the corner. So that's perfect. Now we have a global variable that'll tell us the relative size and the relative position of my walls here. And that's going to be perfect for confining my player within these values here. But we need to do something else before we move on to actually confining the player. We need to assign these values of boundary position and boundary scale at the beginning of the game. Otherwise, our code for confining the player's movement won't work until the screen's already shrunk one time. So the easiest way I've found to do this is just go ahead and call the shrink function at the game awake here. Yeah, it'll shrink the playing field by 1 penalty unit, but it'll go ahead and initialize or assign the value of boundary position and boundary scale. Otherwise, we would have to create some more logic and more like saying if it's in start, then don't actually shrink it. Just I don't know. Or we have to specify, okay, boundary position equals, we have to specify exactly which boundary in our array right here, but then, I press play. You're not guaranteed which object in the array you're going to be looking at each time. So I've found that just shrinking the arena when you start the game is the quickest way to assign values to those. And the player won't see it. The player will never know. They'll think that the boundary's always been that size. And you can even, make if you don't want the size to shrink at the beginning, you can go ahead and adjust the size of the boundaries, their initial positions if you wanted. But I'm going to go ahead and my void awake, just call shrink boundary. And that'll call the function. That'll shrink the boundary at the beginning of the game. And here I can show you what I'm talking about here. So as you start, it automatically comes down and shrinks. But if I put the game on its own screen and maximize on play, if I press play, this is what the player's going to see. They didn't even notice the shrink. They think that's the original size of it. But what we've done is we've gone ahead and assigned values to boundary position and boundary scale. That's going to be very important because we want the player to be able to have those values to know how to confine the player at the very beginning of the game there. All right, so with that done, I think we know 3 things now. We know how big the playing field is with boundary scale. We now know where the playing field is with boundary position. And we can access these variables anywhere within our code because they're public static. So now we get to move over to our player mover. So our movement is based on directly updating, in this line of code right here, we're directly updating the transform.position of our player. So we're physically updating, or we're manually rather updating. Let me get out of that maximize view so we can see what's going on in our inspector. We are manually updating our position X and our position Z of our transform component and its position values. So that's going to give us a lot of direct control over how to limit our player. Say once we can say, okay, we're hitting the wall here, as you can see in my game scene right here. We've hit the wall, and we've hit the wall at this player value right here, at negative 9.7. So now that we know where our boundary wall lies, we can compare where the boundary wall lies to our current player's position. And then we can say, okay, if I've gone over my X value in my player's position, then I can't go left anymore. The game just won't let me go left anymore. So why don't we go ahead and code that in? And to do that, we're going to have to make yet another conditional check for each of my input keys here. So if I press the A key on the keyboard and I'm not moving vertical, now we're also going to say, and my position is within or less than the wall on the left side, then I can move. But if my position is greater than the wall on the left, then I'll skip this line of code and I won't be able to fire off the move function down here. So it'll just stop updating the player's position with this third conditional check we'll make. So how do we code that in? Well, what we're going to say is we're going to say game object, which is our player, dot transform, dot position, dot x, and then we're going to say if it's greater than or equal to our, and what we're going to do is we're going to call on our public static functions over here. So we're going to say gm dot boundary position. All right. So there's that. Let's see. Let me get rid of some of these parentheses. So there's a little bit of logic we have to go through here, get it to exactly work. What we're trying to do is we're comparing our current position X to the overall boundary position. But since this boundary position is kind of like in our console, it's kind of just a general number right here, net 9.6. Well, what if we're trying to find the boundary for my left wall, but the position for my left wall is negative 9.6? Well, that's how we're going to account for that. We're going to account for that here in our third conditional check for our if statements when we press the A key here. So for this particular left wall, we're going to say if the player's position is greater than or equal to, and then in parentheses, we're going to say the negative value of my boundary position, and hit Control S. So basically what we're saying is, let's fix some of those compiler errors real quick. And I just need to add an extra parentheses right there. Control S to save that. All right. So basically what we're saying is we have just a general boundary position right here that at the current time is 9.6. Our left boundary right here, let's go ahead and press play. Right now, our current left boundary is negative 9.8. All right. Oh, and there we go. What we're seeing is our player's value, we go left, then eventually it equals greater than negative 9.8. So that's what this code is saying right here. We're saying as long as our player's position is greater than negative 9.8, then we can move. So our player's position is negative 6. Negative 6.9 is greater than negative 9.8. But as soon as we go negative 9.86, it's greater than, or it's less than, rather, negative numbers. So what we're doing is we're getting stuck in this wall, but we're really not getting stuck in the wall. We're just saying, hey, don't update this player's position anymore. He's already hit past our game object's position there. Our game object's position in the X. But we'll notice something else too. I mean, you probably don't want to physically go into the wall here. So what we'll do is we'll add a little bit of code here. We'll just add one more value. We'll do boundary position +1. We'll hit Control S. And basically that'll stop us 1 unit short of going straight into the wall. And this might be a value you'll have to change. I get that update out of here. This might be a value you'll have to change depending on what your game object looks like. So maybe if I do 1.2 F for a float, let's look and see how it stops us there. Yeah, it kind of stops us a little bit shorter to the wall. So there's my player not being able to go past the wall. All because his position became less than my generic boundary position, and we have to make it negative because, our left wall is living in negative land over here. And that's basically what we're going to do for each one of these if statements here. We just got to find the right kind of conditional check. Is it less than or greater than? And am I looking for the negative or positive boundary position here? So we're going to just copy and paste that line of code and repurpose it as we go. So now we're going to figure out for the right wall here. So let's figure that out together. All right. So right now we have the same amount of we have the same line of code figuring for our left wall. So I know it can't be the same because we're dealing with a brand new wall here. So let's look at what our right wall is saying. Our right wall has a positive position of 10 in the x-axis. So let's say right now we're saying that if my player's position in the x is greater than negative boundary position, why don't we say our player's position, as long as it's less than or equal to the general positive boundary position minus this little buffer value right here. So we're saying as long as our player's position is less than our right wall's boundary, we're able to move around. So there's my right wall, and I'm going to select my player here. And why don't I go ahead and zoom in over into this right wall. So let's pay attention to a few things. Let's pay attention to when our player actually hits this wall. Let's pay attention to the player's X position right here. I'm going to go ahead and reset it to 0. And let's see what happens whenever it reaches. There we go. Because currently, my right wall's positional value is 9.8. So when my player reaches 9.8 minus our buffer value right here, so it doesn't go over that value, we just stop short. So what we're getting is, if I look at my game view, I can't go past the game wall here on the left, and now I can't go past the game wall on the right. It's just not updating my player's position anymore. But I haven't checked I haven't solved for the position on the top and bottom, so I'm going to do that now. And again, it's just almost the exact same lines of code. But this time we're going to be looking at the position in the Z. So Z. And then for our W, what we're going to say, let's see. What do we say for our W? Well, let's figure it out together by physically looking at what our player's doing in our scene view. So this is my top boundary right here. So I'm going to move my player close to my boundary in the top here. So right now, my player's position is 8.81. If it gets above 11.61, so I'm outside of my wall here. So I'm basically my position is basically higher than the wall's position. So I got to say, okay, as long as I'm within or less than the position of the top wall, I can move up and down. So what we'll say is, okay, my game object's position in the z-axis now, the z-axis, because we're moving up and down, if that's less than or equal to the boundary position, the overall boundary position, then I can move up and down. And then there's that buffer value again that keeps the cube from colliding direct or going straight into the wall. So that looks good. Let's go ahead and press play and test that out. Yep, can't go up in the wall there. All right. I think I might have messed with the value of this top wall here. There we go. And what we're going to do is we're going to use the same kind of logic down here. So since everything's kind of similar, I can deduce that it's going to be kind of the opposite. So we're going to do a greater than or less equals to, and then we're going to take the negative value of my boundary position because my bottom wall lives in negative town in the z-axis down here. So we'll say as long as my game object's value in the z position is greater than the negative boundary position. So as long as I'm like -4 or -3, then I'm good. So that's that value, -4 value in the z position, is greater than the position of my wall currently. So we'll hit Control S, and what we're getting is I can't move outside of my boundary now, no matter how hard I try. So perfect. So an interesting thing happens though. You think it's all well and good, but look what happens. I'm shrunk. I'm outside the player boundary, but look, I can go back in, but now I can't get back out. It's shrinking on top of me. That's no good. What we need to do is if the player is around the border of the playing field, because look, I mean now he's just kind of like when it gets too small, he's going to be really close to those borders, so there's a good chance that he's going to be able to get shrunk down on. So we need to have some lines of code that handle updating or pushing the player's position so that they don't, get outside of the boundaries position there. So that's going to be somewhat easy. What we're going to do is in our player mover, in our update, we're going to go and create some new lines here below all of our input commands here. These are our input commands that we've worked with. We're going to make some new if statements down below them that check our player's position in relation to our boundary. And then if we're on the border, if we're too close to the border, it's going to push us in the direction that we need to stay within the boundaries of our playing field. So what we need to do is we need to have 4 checks to compare the current position of the boundary to the player. So what we'll do, and they need to be separate if statements in case you need to reposition in the horizontal and vertical axes. So it's going to be 4 separate if statements. And we're going to say if our current game object, which is pointing at our player, or the script that this player mover is attached to, which is going to be the player, if its transform dot position in the x is less than our negative gm dot boundary position, then that's going to be, let's see, this is our left boundary check. Okay? If our player's position is less than our negative GM boundary position, so we're in our x-axis, which means it's horizontal, and our negative boundary position means we're probably dealing with our left boundary check. If our player's value is less than the boundary, so if our boundary is at negative 10 here, and then our player is all the way over here in negative 14 land, negative 14 is less than -10. So that will fire off that check. So what we'll do is we have to do some code here. So I'm going to save the body of code for a little bit. So I'm going to copy and paste this. I'm going to go ahead and make my 4 conditional checks. I'm going to separate them by a line since they're not directly tied to one another. So why don't we do our right boundary check. So if our player is against our right boundary over here and the playing field shrinks on him, we're going to be able to check and see if the boundary is clipping into our player with this line of code here. And it's just, if our player's position is greater than our positive boundary position, then yeah, we got a problem. Our player is inside of the wall. And again, why don't we do our top and bottom checks now? So we're going to be dealing in our game object transform position.z. So if our player's position in the z axis are up and down axis in this current setup, and why don't we solve for our current bottom boundary check? So it's going to be negative, and we're going to do if our player's position in the z-axis is less than the negative boundary position, then yeah, our bottom boundary plane, our bottom boundary cube is clipping into our player. And then I'll just change it for our top. I'll change the direction of that, get rid of the negative sign. And this is my top boundary check. Hit Control S, and now I have a bunch of boundary checks here. And why don't I do some debugs dot long, and we can say left. So this is just going to fire off just to make sure I got the logic right in all of these. And I'll just update. So that's my right. Bot top. Control S to save. All right, so now let's look at and there we go. We're getting constant rights. I'll collapse this. See our right statement right here? I'm outside of my right boundary, so Unity is going crazy right now. It's saying over and over every frame, right, right. We've gone outside of my right boundary. So instead of doing a debug.log check, now we need to actually physically move the player's position. So to do that, we first have to make a current position variable for our player here. So we're going to make a vector3 current pos for the current position of our player, and that'll make updating his position a lot easier down here in our code here. So why don't we update our left boundary first? So we'll say transform. Well, first, actually, yeah, that's right. We need to update the current position of our player. So anytime, what is with this formatting? So anytime we hit the wall or the wall is about to swallow us, we need to do two things. We need to update our current position to GameObject.transform.position of our player. So we know the current position of our player. That'll make the next line of code even easier to do. And we'll say transform.position. Well, let's make it even more clear. Our current game object, which is our player, transforms position. So we're going to update this new position by saying equals new vector3, and we're going to say current position dot x, because our new vector3 has an x, y, and z values. So the current position of our player, the current position being the game object's position. So the current pos.z.x value, we're going to update it. So it's the current value plus, let's say, 1. And that +1 right there will go a long way. We'll actually shove our player in the right direction. So then we just have to say current position Y and current position dot Z, like so. Game object cannot exist in this context. That's because I probably need to capitalize object. There we go. All right, so let's test this. Okay, so we're noticing something here. We did get pushed, but only until our player's basically engulfed by our boundary here. So we need to shore up our code here. So as soon as our player collides with our wall right here, he's getting pushed before the wall swallows him. So let's figure out how we can do that. All right. So let's look and test our game a little bit more and really hone in on what's happening as the game progresses. So I'm dealing with my left wall right now. So I'm going to zoom into my left wall in my scene view. So a few things are going to happen. I'm going to go over and collide with the wall. I can't move into the wall anymore. I've hit the limit, and I'm going to shrink it. So right there, the wall's already kind of hitting my player, but yet we're not getting my warning sign yet. So if I keep pressing left, I still haven't gotten my warning sign. I still haven't got my warning sign. It's still eating me. The wall is eating me right now. Still haven't got it. Still haven't got it. But there we go. I got it. It was almost until the wall completely swallowed the cube that I got pushed back and my warning left sign came up in my console window. So we need to fix that. So here's the line of code right here that's checking to see whether my player is colliding or is in the same position as my boundary cubes. So what we need to do is we need to add another buffer here. So the boundary position of my wall, it's actually measuring the exact center of the wall here. So it's looking for this position right in the center of this game object wall, cube wall we've made. So we kind of need to make a buffer so it's looking for the value on the right side of the wall. So as soon as the right side of the wall hits my cube, then it pushes me back. So what we'll say is my boundary position plus 0.8 units. And that'll shove what I'm looking for. Instead of measuring from the center of my wall, it'll shove what I'm looking for to 0.8 units to the right. So now when I get my cube close, there, it pushes me. But look, it's almost pushing me too much though. So if I'm looking at it this way, see how it's pushing me too much? That doesn't look good. We want it just to kind of push the player just enough as if it's really being pushed by the wall and not being thrown back like by a force field. That looks jarring. So we're going to make a few more refinements here. So we got that pretty good. This little buffer allowed us to detect whether or not our player was getting pushed from the center of the wall or the actual physical side of the wall here. So that's good. You know, we're being pushed without being swallowed, but we're being pushed too far. So that's what we need to fix now. All right. So if I go into my position update and current position .x plus 1, so I'm being pushed 1 unit right here. That's what I've defined. What if I was pushed by 0.5 units instead of a whole unit? All right, let's see. Still pretty good, but it's almost still like the wall's pushing me. Let's see. All right, all we have to do is just keep tweaking this value right here. Let's do 0.2. So this new vector 3 that we're updating, we're taking the current position of our player and we're adding 0.2 units So we're effectively pushing it 0.2 units to the right here. And that looks pretty good. Since our player is right on the wall there, we're checking it, we're being able to detect it, and then we're just pushing it. We're just pushing it to the right. We're adding 0.2 units to its position over here in my inspector. And that way the left wall is effectively in quotation mark. I'm making quotation marks right now, pushing the player. So I'm not going to worry about making a function to repeat these lines of code. It's only 2 lines of code. So what we'll do, and I'll go ahead and get rid of these debug.logs. So I'm just going to go ahead and copy these lines of code. And all I have to do is change what position is in the X or the Z value right here. That's the only thing I have to change for each one of these little if statements. So in our X statement, all we have to do is subtract 0.2 because our player on the right side here, we're going to subtract 0.2, so he gets pushed back by 0.2. So subtracting position the negative and 0.2, that's good there. And then instead of X, we're not going to add 0.2 to the X. We're going to, let's see, what is this, my bottom boundary? We're going to add 0.2 in the Z position because now this is my bottom boundary check. So we want to push the player up in the Z. Let's say they're at the bottom here. We want to add 0.2 to our Z value. And then we'll just do the same for top. We'll get rid of that. We'll keep the current X and Y position as they are, but we'll subtract 0.02 from the Z. I've saved. I'll hit play. And I've broken something horribly. Let's see. I've moved the actual player mesh instead of the player game object. So that is really messing him up. So be careful of that. I should have just been moving the actual player object there. All right. There's my movement. So, but you know what? We didn't go back and figure for the wall swallowing the player and the up, right, and left. See, it works for that as we get down here. So why don't we go back and fix the code there? So how did we get that? Okay, so we went to the actual if statement that checked for the left boundary check, for instance. So we need to do the same over here. So the right boundary check. So instead of doing that, we're going to do -0. We're going to subtract 0.8f from that. Yeah, I think that's definitely right. And we just need to add 0.8f to the bottom. There we go. And subtract 0.8f. So as we're checking the position of our player against the position of our boundary right here, then we need to make sure we have that little buffer of 0.8 so the wall's not swallowing our player. So now if we go in and test the game, and look, it even works if we're in the exact corner. And now our player is completely trapped in the middle of our boundary. All right, and that does it for confining our player to our play area.